The last star in the universe will not die for another 100 trillion years. No sun, no light, just a slow fade into permanent darkness. But what is even crazier is that most of the universe's stars have not even been born yet. Right now, the cosmos is still in its infancy, and the end of everything is so far away that human history is less than a rounding error against it. This is a countdown through the final chapters of existence itself, each one stranger and more absolute than the last. The first ending begins with the stars simply going out. Stars are giant furnaces that burn hydrogen into helium, and hydrogen is a finite resource. Take a galaxy full of stellar nurseries producing new suns, and slow that production down year after year, and eventually you get a universe that stops making new light. Astronomers estimate this stelliferous era, the age of active starlight, could stretch on for roughly 100 trillion years before the last ember burns out. No new stars. No new warmth. Just the slow disappearance of every light in the sky. But here is the unsettling part. Even after the stars are gone, the universe does not simply stop. After the last star fades, what is left behind does not vanish, it lingers. Dead stars collapse into dense remnants called white dwarfs, and white dwarfs are corpses of stars that have run out of fuel entirely. If you could stand near one, you would find an object roughly the size of Earth, but packed with the mass of an entire sun, glowing faintly from leftover heat with nothing left to burn. These husks will take an estimated 10 to the power of 15 years, 1 quadrillion years, to cool into cold, dark spheres called black dwarfs. No star has ever actually become a black dwarf yet, because the universe is not old enough, but the math says it is coming. And that leaves us with a universe full of frozen corpses drifting in permanent night. But even dead stars are not the end of matter itself. Deep in theoretical physics lies a chilling possibility called proton decay. The idea that protons, the particles that make up every atom, might not be permanent after all. If protons decay, then over spans of time longer than 10 to the power of 34 years, ordinary matter itself would slowly dissolve, atom by atom, until nothing solid remains anywhere. No rocks, no planets, no frozen stars, just a faint mist of subatomic particles drifting through endless space. This has never been observed, and detectors built specifically to catch it have so far found nothing, but the theory refuses to die. So what happens if the very atoms that make up your body are not permanent at all, but simply slow-burning fuses lit at the beginning of time? While matter quietly dissolves, something even stranger is happening to the fabric of space itself. Astronomers discovered in 1998 that the universe is not just expanding, it is accelerating, pushed outward by a mysterious force called dark energy. Take that acceleration and let it run forward for trillions of years, and you get a scenario called the Big Freeze, where galaxies are pulled apart so violently that the night sky over any surviving world would eventually go completely black, with no other galaxies visible at all. Right now we can still see billions of galaxies, but this accelerating expansion means future observers, if any exist, will see almost nothing beyond their own. No neighbors, no light from beyond, just an island of stars, marooned in a growing void. But the next possibility on this list does not just push galaxies apart quietly, it tears everything apart with violence. If dark energy is not constant, but actually strengthens over time, the ending changes completely. This scenario is called the Big Rip, a hypothetical future where the expansion of space grows so powerful that it eventually overcomes every other force in existence. First, galaxies would be torn from their clusters, then solar systems would be ripped apart, then planets, then atoms, until in the final fraction of a second, even the tiny bonds holding subatomic particles together would be shredded apart. Current data suggests this outcome is unlikely, and the properties of dark energy so far appear stable, but the possibility has never been fully ruled out. No structure, no distance, no force strong enough to resist it, just an ever-accelerating tear across all of existence. And if space itself can be torn apart, you have to ask what space actually is at its core, because the next entry suggests it might not be as stable as it looks. If you have made it this far into the final chapters of the universe, drop a like and subscribe, because the next possibility on this list is not about things slowly fading or stretching apart. It is about the sudden and total rewriting of the laws of physics themselves. Physicists describe our universe as sitting in something called a false vacuum, a low-energy state that feels stable, but may not be the most stable state possible. Imagine a ball resting in a shallow dip on a hillside, appearing settled, while a much deeper valley waits just beyond the ridge. If a region of space were to tunnel into a lower, truer vacuum state, a bubble of new physics would begin expanding outward at the speed of light, converting everything it touches into a different version of reality, one where the fundamental constants are no longer the same. This event is called vacuum decay, and if it happened, there would be no warning at all, because the bubble wall would arrive at the same moment as any light announcing it. No signal, no delay, no possible detection beforehand. But even an event this absolute is not considered the most likely ending physicists actually study, because the next entry does not need new physics at all, only old physics running out. Long after stars, matter, and even space-time behave predictably, entropy becomes the final judge. Entropy is simply a measure of disorder, and the second law of thermodynamics states that total entropy in a closed system always increases over time. Take a universe full of energy differences, temperature gradients, and organized structure, and let entropy run its course for long enough, and you get a state called heat death, where everything reaches the exact same temperature and no energy can move or do work anywhere. This end state, sometimes called maximum entropy, would leave no stars, no chemistry, no motion of any meaningful kind, just uniform, silent stillness stretched across infinite space. No hot, no cold, no exchange, just perfect, permanent balance. And here is where things become strange, because balance is not necessarily the same thing as an ending. Some physicists argue that heat death is not actually final, but only appears that way on human timescales. In a universe of true maximum entropy, given long enough, quantum fluctuations could still occur completely at random, popping tiny pockets of structure into existence out of nothing at all, over spans of time so vast that ordinary numbers stop being meaningful. These fluctuations could theoretically assemble anything, including brief, isolated conscious observers called Boltzmann brains, momentary minds that appear briefly in the void and then dissolve back into nothingness. This idea remains a genuinely unsettled debate inside cosmology, used mainly as a stress test for whether our models of the universe's fate are actually complete. Nobody knows if this could really happen, and given the timescales involved, nobody alive could ever confirm it either way. But if isolated minds could theoretically flicker into being from pure randomness, that raises an even bigger question about how our own universe began in the first place. Some cosmologists propose that endings and beginnings might not be separate events at all, but the same event viewed from different sides. In certain models, an extremely low entropy, high energy fluctuation, similar in principle to the kind just described, could theoretically be dense and ordered enough to trigger an entirely new expansion a new Big Bang branching off into its own separate universe. Take an ending defined by maximum disorder and thread through it a single, vanishingly rare pocket of extreme order, and you get, at least mathematically, the seed of a new cosmos entirely. This idea exists at the very edge of testable physics, and most cosmologists treat it as a fascinating possibility rather than a confirmed mechanism, since it currently cannot be directly observed or falsified. No confirmation, no evidence yet. Just an equation suggesting that endings and origins may not be as different as they seem. Every version of this countdown, the freeze, the rip, the decay, the silence, shares one unsettling thread, which is scale. Human civilization has existed for a few thousand years, our species for a few 100,000, and Earth itself for about 4.5 billion. Set that against 100 trillion years of starlight, or 10 to the power of 34 years of decaying matter, and human history does not even register as a rounding error against the lifespan of the cosmos. And yet somehow, right now, in this narrow sliver of cosmic time, stars still burn, galaxies are still visible, and a mind exists capable of calculating all of this in the first place. No guarantee this window stays open. No promise it lasts. Just this exact moment, borrowed from an almost incomprehensibly long future of silence. If you are not ready to leave the edge of time just yet, there is a full playlist waiting exploring the universe's strangest black holes, its most extreme stars, and the outer limits of physics itself. Subscribe before the universe ends, and we will keep walking this path together, one impossible fact at a time.